Number 3, what I notice is there are no squares at all anywhere. Everything's sines, cosines, cotangents, something like that. Whenever I see no squares, nothing that's being squared, I think if there are no squares, change all to sine and cosine, and then see what happens. For example, I already have the sine of x to begin with, so I leave it as sine of x. But anticipating, of course, that cotangent is a fraction, I'm going to put the sine of x over 1. So that was this thing. Cotangent is cosine over sine. And cosine is cosine over 1. So now I see everything in terms of sines and cosines. And what I notice is on the right-hand side, if I were to multiply this out, I would see a fraction with a denominator of sine. But on the left-hand side, I don't see the denominator of sine. So in order to work with fractions, you always have to have a common denominator. To that end, I'm going to take the left-hand fraction and multiply it by sine over sine, so that now, on the left-hand side, I will see sine squared of x over sine x. On the right-hand side, I will see cosine squared of x all over the sine of x. Do you notice how now that they have a common denominator? When fractions have a common denominator, you can put them together. So now I can write this as one fraction. I can write it as the sine squared of x plus the cosine squared of x all over the sine of x. In the numerator, that is the most famous trig identity. Sam?
1.
It is 1. So the numerator, if you were to simplify it, turns out to be 1. And that's it, because sine squared plus cosine squared equals 1. On the bottom you have the sine. And we all know that 1 over the sine is really the same thing as cosecant. So all that mumbo-jumbo in the red, light blue, and pink turned out to just be the cosecant. In number 4, I noticed that there is a square in there. And then they use the word factor. That's another thing that they're telling me. But the problem is I don't know how to factor that because I don't see anything that's the same. So I'm not really sure what they mean by that. So then what I do is I go back on the front page of my notes that I just got from my favorite math teacher this year. And I notice that cosecant squared says something to me on the front side. I notice that the cosecant squared is really the same thing as
1 minus sine squared.
no.
1 plus the cosine squared.
Please raise your hand so I know instead of all the babbling. Drew.
1 plus cotangent squared.
That's correct. 1 plus cotangent squared. On the front, under the Pythagorean identities. And so now I also still have minus cotangent of x minus 3. Take a look, see if you can find it. So now I'm going to simplify this first before I go any farther. I'm going to, oh look, the 1 and the minus 3. They could probably go together. I mean, it's not really close to prom, but whatever. That was some light math humor. Good job.
I got it.
Thank you, Joe. So I just put the 2 and the negative 3 and the 1 together to make negative 2. I wrote it in descending order, highest power, next highest power, power of 0. And then, of course, I notice that I can now factor this thing. And you will see this immediately, probably after I write it down. I have the cotangent of x minus 2 times the cotangent of x plus 1. And that's it. That's your finished product. Fisher!
Rice. Toys.
You look at this thing, number 5. What's the first thing that pops in your head? Shut up, I'm not talking to you guys.
Oh, Fisher, say something.
No. I said what's the first thing that pops in your head? Oh, he called on me. That's the first thing that popped in your head. Don't even lie.
No.
Was it? I was like, I really like Sarah's shirt. That's on video. I recorded that. Yeah? Awesome. Alexis, what's the first thing that popped in your head?
Sine and cosine.
Sine and cosine. Excellent. Adam.
Division and addition.
Division addition. Gannon.
Cosine and sine equals cotangent.
Okay. Maddie.
Theta.
Awesome. Lily.
Hi.
Good morning.
How are you?
Fabulous. Great. What popped in your head?
No squared.
No squared. You know what popped in my head? 2 fractions.
Cross multiply.
No. Common denominator. Cross multiplying is with an equation. So you need a common denominator. That's what popped in my head. That means that on the left side, I see a 1 plus cosine on the bottom, but I don't see the sine. So I'm going to multiply that fraction by sine over sine. Because now it will have a sine as well. On the right-hand side, I don't see a 1 plus cosine. So I multiply the top and the bottom by 1 plus cosine. And what I do see now is both fractions have a common denominator. Let's pick on John Day. John, do you know anything about the Waltons? There used to be a show a long time ago. It was a family show called The Waltons. And at the very end of every show, they'd always go, "Good night, John boy."
Oh, yeah.
Have you heard of that?
Uh-huh.
Yeah. It was excellent.
Sometimes I'd say that.
What do you think about this stance? Do you like this?
No.
Why do you keep looking then?
What's your hip up in that?
In the left fraction, sine times sine is sine squared of theta. Here, let me help you. Just in case you didn't see it. There it is. The second part, this thing. If I multiply those two together, I get cosine of theta plus,
Cosine squared theta.
excellent, thank you, cosine squared theta. And you probably know that the common denominator is the sine of theta times 1 plus the cosine of theta. I'm just going to leave it like that for right now. I want to call your attention to something really interesting. Here it is. The interesting thing I want to call your attention to is, what's 7 plus 3 plus 5?
That's good.
Well, 4 people know that. That's good. 15. How about, what is 3 plus 5 plus 7?
15.
15. Notice how it didn't matter what order I added them in. They came out to be the same thing? Okay.
Wow.
Well then, I'm now going to do this.
So sine squared.
Shh. Don't give it away.
Yeah. Let's show lips.
Do the Helen Keller.
What?
John, you're up.
Jacob,
Is a continent. Seriously, it's time to pull the junk out of your ears. John, what is this? Right here in highlight. It is a trig function. Shh. I'm asking John, you meatballs.
Meatball.
So it's 1.
It is 1. Good job. It is 1. So now, on the top, I have 1 plus the cosine of theta all over on the bottom. Who's talking over there? Somebody put a diaper on her face. Diarrhea of the mouth. Yeah, that's on video too. Did you guys notice anything top and bottom?
Yeah, both of 1 plus cosine.
Yeah, they both have 1 plus the cosine, which means da 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 da.
Cancel.
And the answer is just
1 over sine.
1 over sine,
Which is
cosecant.
cosecant.
I get it.
which is the same thing as the cosecant of theta. Bless you. That's your final answer.
Wait, why?
Sometimes, most of the strategies that we try, like factoring, looking for Pythagorean identity, changing everything to sines and cosines, don't work. And then weird things work. And this next thing I'm going to show you is something I probably would have never thought of unless somebody showed me a long time ago how to do it. Whenever you have something that's a fraction and there's 2 things on the bottom, one of them's a 1 usually and one's a trig function. The strategy here is to multiply by the conjugate of the denominator. Now you might not remember what conjugate means,